Hey, so this is the second video of our 8-bit computer registers. And this video will cover building, testing, and then overall just how it works. I know in our first video, we talked about our buses, we talked about our ICs, whether it was 74LS245 or 74LS173. And then we'll just kind of go over how everything works together. So for starters, what we have here is we have our A register, we have our B register, and then we have our instruction register. So these were all created, in this section of our video. And then what we have here is a makeshift bus. And then these LEDs will tell us the exact value that's on our bus. And then this is our clock module from our first series. So if we just want to kind of jump straight into it and, go over how it works. Obviously right here, we have that 74LS245. That'll be our buffer. That allows us to have our enable signal. Like I said, we talked about that in our last video. We also have two 74LS173s. Those will be our registers. Those are two 4-bit registers, which add up to make 8 bits. And that was one that we talked about in our last videos with the D flip-flop, and that controls our load input. All right. So we just kind of go over how it works. Or actually what we'll do is we'll take a look at our schematic here. As you can see, we have our 74LS245, our buffer. And then we have our two 74LS173s, our registers. We also have connections from our registers to our buffer, from our register to our buffer. And then these D outputs goes onto our bus. Now we also have D inputs to our registers, and those D inputs come in from our bus. So what's going to happen is we'll get stuff in, it'll store it in zeros and ones. We have LEDs here on these lines. So 1, 2, 3, 4, 5, 6, 7, 8 LEDs to let us know exactly what is inside of our registers. And then what it does is it sends it to our buffer, and then we can either bring enable high or low to determine if we want to output that to the bus. We can either bring low, high, or low to determine if we want whatever data's on the bus to be loaded into our registers. All right. So taking a look at our breadboard again, I really just want to kind of not necessarily put a face to a name, but let's see. So these wires here, or we'll just focus on this one register. So these wires here are the actual connections to our bus. And that's the one thing that we hadn't showed in our schematic. So you see how it kind of stops here, these little D1, D2, D3, D4, all the way to D8, and same on this side. Those represent these green wires here. Now, when we get data, let's just say we're loading. So load is inverted, which means that when load is high, it's actually low, and when load is low, it's high. So basically, when load is high, or in this case low, we get data in from our bus, our makeshift bus, and what it'll do is it'll come through our blue cables here. All right. And once it comes through our blue cables, it'll come here to our two registers, our two 4-bit registers. And our two 4-bit registers will store that data. And then that data, like I said earlier, from our schematic will be outputted onto our LEDs. So this is how we know exactly what's inside. Now, in this case, we hadn't necessarily brought in data from our bus, but when I connected power, these are just the kind of the default values that I got when I first turned it on. But we'll go ahead and bring that in later in our video. So like I said, we have data here. It shows our LEDs, and then what's going to happen is it'll come through these green cables to our 74LS245, like I said, which is our buffer. And then this is our enable signal here, and this is also inverted. So when it's low, it's outputting. So we have it low now, which is actually high, and we're allowing this data on these green cables to go through our buffer back to here to these other green cables connected to our bus, and that's outputting onto our bus here, onto those LEDs. So if you know, as you can see, if I decide to kind of take this out, I'm no longer outputting to my bus. And if I put it in high, you see what I'm saying? Now, if I go back to low, now we get that data. In addition to everything that I just talked about, we also have on pin 7, our which is it's going to be our clocks. Pin 7 is for our clocks on these 2 registers. And the reason we have a clock value is because the registers are going to take in data on a clock's rise and edge. We also talked about that in our last video. So that just, we connected those 2, and then this white wire is connected to our clock. So on every rise and edge, if we want to load, that's when we would load on the rise and edge of the clock signal. We also have 2 yellow wires here. So this first yellow wire will be our clear signal, pin 15 and pin 15, I want to say. And what this does is it allows us to clear whatever is inside of our register. So first of all, I want to stop outputting, or I want to stop enabling this to our bus. And when I bring this high, or when I take it out of low, I didn't even have to bring it high, but when I take it out of low, what it does is it clears whatever is in our bus. So that's pretty cool. So that's pin 15, and those are connected, and that does that. Now we also have another yellow wire, and so this is pin 9 and 10, pins 9 and 10, and we've connected them. And this is our low signal. So, like I said, we've already spoke about that. This is just where it comes from on those two registers. And then, we also have power, which is, self-explanatory, and ground, which is also self-explanatory for the most part. I don't necessarily want to get into that. Now, what we can talk about is we can talk about just the connection of everything, because I know that can be kind of difficult to understand sometimes too. So we have power connected here. This is our, okay. And then we also have power going from here to our clock module. That way our clock can have power. We have power coming from our A register to our B register. And then we also have power coming from our B register to our instruction register. And then not to mention, we also have ground here. And then you can kind of think of these as, like power as well coming in, like positive, I guess you can say, coming in, and then you have the ground. If we begin to talk about our instruction register is similar to our A and our B register, but it's just it's not quite the same. And it's not quite the same first because it's mirrored, which means that we have our 74 LS245 first, and our 274 LS173s. And now it's just because the way the computer is set up, we'll have our bus running right through the middle, and it will be better for us, and we can use shorter cables if we just had it set up like this, because we'll have something in the middle separating it. Now, another big difference is you can see that there's a lot less green wires. So like I said, our blue wires are connected to our bus here, and that stores data inside of our registers. So we're still getting, all of our LEDs are still lighting up. We still have data inside of our registers, but the only difference is when we go to output, we'll only get these 4 bits that output to our bus. These 4 blue LEDs, they won't output to our bus. And that's, you can just kind of tell because we don't have the outputs of this register connected to our buffer with those green wires to output back to our bus. Okay, so I'll show you guys really quickly. This is our enable here to our bus. We bring this low, which is actually high. And as you can see, we only get the 4 least significant bits that power on because, like I said, these won't output. So we can turn this off now. So now I want to jump right into testing our registers. What we'll be testing for is we want to make sure that each of our registers can input, each of our registers can output, and then they can swap values. So if they can input and output, then they can swap values anyway, but we'll still go ahead and test that and make sure everything's working how it's supposed to. So first, we'll go ahead and enable our B register. So our B register can output to our bus. Everyone is on except these two LEDs, and that's the same here. So that's a good sign. We want to output from our instruction register. Every one of them is on. So we got our 4, and then we want to output from our A register, or enable. We want to enable our A register. And each and every one of our LEDs power on. So that's good. So next, what we want to do is we want to load to each register. So to do that, what I'll do is I'll enable my B register because it has a different value than my A register and my instruction register. So now what we can do, because that one has a different value, I'll be able to see if it actually loaded or not. That's the only reason I did that. So I took this out here, and on the next rising edge of our clock circuit, that went ahead and loaded into our A register. So that works. And then I put it back high so that it's not load anymore. And then we'll go ahead and do the same thing here. And on the next rising edge, it went ahead and it loaded that same value that was on our bus. And then lastly, I want to make sure our B register can load. So we'll stop enabling here. We'll enable here on our instruction register. Or that was our load. I didn't mean to do that. But we'll enable here on our A register. And then we'll go ahead and load on our B register. And on the next rising edge, we went ahead and got all of those, those LEDs to turn on. So what you saw is you saw each register input, you saw each register output, and you saw our registers swap values, which is a great thing. Lastly, I want to talk about a problem that I encountered while I was building my 8-bit registers. So when I built my registers for the first time, I had no problem enabling to my makeshift bus. If I brought my enable signal low, which is actually high, it outputted to our bus, but I couldn't load from my bus to my register. And what I found is that we needed resistors on our LEDs, current limiting resistors, 220 ohms. And then I was able to load and enable from each of my from each of my registers to my bus, or to each of my registers from my bus. But yeah, so that's how I solved my problem. So if you are having an issue where you can enable to your bus, but you can't load from your bus, then maybe you should get some LEDs with current limited resistors built in, or if you know how to solder, I just use 220 ohm resistors. I think 150 ohm, if they have those, will be just fine though.